This is part 2 of our mini course on failure analysis in semiconductor industry. Failure analysis in the semiconductor industry plays a vital role in ensuring product quality, reliability, and continuous innovation. As electronic devices become smaller and more complex, identifying the root cause of failures becomes increasingly important. Quality assurance depends heavily on timely failure analysis to catch defects before they reach customers. This supports customer satisfaction and reduces costly recalls or warranty claims. Advanced analysis techniques such as electron microscopy, spectroscopy, and fault isolation are used to investigate failures at the microscopic and atomic level. These tools help engineers understand not only where a failure occurred, but why it happened. The insights gained from failure analysis directly contribute to process improvement, enabling manufacturers to refine fabrication steps, materials, and designs. By understanding how and why failures occur, companies can build more robust and reliable products, fueling ongoing innovation in the competitive world of modern electronics. Benefits and future outlook. Transforming the semiconductor industry involves significant gains across quality, cost, speed, and innovation. First, a 99.7% quality improvement represents near-perfect output, signaling vastly reduced defects and far greater yield reliability in manufacturing. This improvement is especially critical for advanced nodes, where even minor flaws can lead to device failure. Second, a 65% cost reduction suggests tremendous operational efficiency, achieved through automation, better process control, and smarter resource management. This cost drop can make previously expensive technologies more commercially viable. Third, an 80% faster resolution means quicker identification and correction of issues, reducing downtime and boosting throughput. Faster problem resolution is key to meeting the demand for shorter product development cycles. Finally, tripling the innovation rate shows how these changes fuel creativity and accelerate the adoption of next-generation solutions. Together, these metrics highlight a transformative leap in semiconductor performance, competitiveness, and long-term industry growth. Benefits and future outlook. The semiconductor industry is already realizing powerful benefits and has a clear path toward even greater advancements. Currently, zero-defect manufacturing is a key achievement. Through proactive detection and elimination of failure modes, manufacturers can dramatically reduce rework and waste. Massive cost savings follow naturally by avoiding expensive recalls and halting costly production line shutdowns. Accelerated innovation is another highlight. Deep data insights help improve design and process iteration for next-generation devices. Enhanced reliability is also a major gain, as products now last longer and perform more predictably due to stable process controls. Looking ahead, the future trends are equally promising. AI and machine learning will allow predictive failure detection based on massive datasets. Automation will drive self-managed workflows with minimal human input. Predictive analysis through digital twins will prevent issues before they arise. Nanoscale precision will deliver sub-nanometer resolution, essential for advanced nodes. The technology roadmap is clear: pattern recognition by 2025, real-time analytics by 2027, and full autonomous failure prevention beyond 2028. Failure analysis, the foundation of semiconductor excellence. The global market for failure analysis in semiconductors is valued at $2.8 billion as of 2024, and it's growing fast, with an annual growth rate of 15%. This growth is driven by the need for improved quality, reliability, and innovation in semiconductor products. Over 100 million devices are analyzed daily, reflecting the scale and importance of failure analysis in high-volume manufacturing. It has moved from being a reactive tool used only after defects occur to a proactive enabler of technology development. Failure analysis today plays a critical role in shaping the future of the industry. It supports continuous improvement by uncovering root causes early. It acts as an innovation driver, helping engineers fine-tune designs for next-generation technologies. It also sets benchmarks that establish industry standards. In short, failure analysis is no longer just about solving problems. It's about enabling tomorrow's technology today through quality excellence and future innovation.